Now let's look at the next question that you had in the set. So this was on page 2. Now it included a part C, which is to do with calculus, so you don't need to attempt that at the moment. Joan is playing golf and she's 150 meters from the center. So this is the distance that she is. Let's just add that in to the center of my diagram straight away. So we know that this distance is 150 meters, 150 meters there. We also know that the diameter of this circle, this green diameter, is 30 meters. So I now know this length and I know this length. Why is that 15? Because it is the radius of the circle. It's the radius of the circle, so it's half of the diameter. So I can mark that in to my diagram as well. They want us to find the measure of the angle alpha down here. And I hope that you'd agree that I will have two identical right-angled triangles here. So this angle in here on its own is half of alpha. So if I sketch out that right-angled triangle, you don't need to use a ruler or be very accurate. Just have a quick sketch, and rather than calling this alpha, let's just call it the angle A. That's half of alpha. And we know that this is 15 because it's the radius of my circle. And we know that the hypotenuse, because it's the side opposite the right angle, is 150 because that's the distance to the center, as we're told. Now, we have a right angle, we have two sides, we have a right angle triangle, we have two sides. We're trying to find an angle, so we're going to use SOHCAHTOA. And the two sides that I have are the opposite and the hypotenuse, so I can use the sine of the angle there is going to be 15 over 150, which is a tenth. And we can calculate the value of sine. We're looking for the angle. You use sine inverse. So A is going to be sine inverse of 1/10. And they asked us to do it correct to one decimal place. So sine inverse of 1/10 or 0.1. And it's 5.7 degrees. Let's say 5.7 degrees, but that's not my final answer because that's only half of alpha. So therefore alpha is going to be twice that. You can just use the answer in your calculator, multiply by 2, 11.5. So it's going to approximately be 11.5. Now, interestingly, I'll get 11.4 if I multiply that out. Would I lose a mark for rounding too early? Probably not. So if you take it from the calculator, it will be 11.5. Which one is more accurate? This one. Okay, so that's just showing that we can get rounding errors if we round too soon. But if you show all the steps, they won't remove marks from you when they're correcting it. Okay, the second part then. At the next hole, Joan at T attempts to hit the ball in the direction of the hole, which is at H. Her shot is off target and the ball lands over here at A. So we've got a triangle described here, and it's not a right angle triangle. This angle here is 18 degrees, ATH. So the middle letter tells us where it is, but the diagram does as well. The distance from T to H is 385 degrees, and they want us to find the distance from A to H. So what do we have? A not right angled triangle means sine rule, excuse me, or cosine rule. The angle is between the two known sides, so we will use the cosine rule. Now, if you weren't sure, a squared is equal to b squared, plus c squared minus 2bc cos a. If you weren't sure whether to use the cosine rule or the sine rule, then if you tried to use the sine rule, it just wouldn't work out. And the other two sides are b and c, and it doesn't matter what order you put them in. So I'm filling in to this. This is the side I'm looking for, a. A squared is going to be 190 squared plus 385 squared minus 2 by 190 by 385 by cosine of 18. You know, you could even do the square rooting all at the same time, but just so that we don't end up spending ages typing something into a calculator and then getting an error, we've got 190, let's type it in, 190 squared plus 385 squared minus 2 by 190 by 385 by the cosine of 18. Okay, so it's quite long. Type that into our calculator in one go and we get 45,185.43. Go to two decimal places, that's a squared, and then square root both sides to find a, which is the distance from a to h, and that is the square root of 45,185.43, and that is, they said to the nearest meter, 212.57, and that's approximately 213 meters to the nearest meter. Okay, so like I said, part C was not something I wanted you to attempt. Looks like a complicated question, but when you sit down with the triangles, right-angle triangles are usually SOHCAHTOA or Pythagoras, not right-angle triangles, cosine rule or sine rule.